This is the last video in the series of videos I have been releasing every day for the last 15 days. Now with the exam NEET a couple of days, I don't think it's the time to take any extra question. So in this video, I just wanted to give some general tips on while facing physics in a competitive exam like NEET or JEE mains or something like that, especially in the form of MCQs. Some of the general hints I just want to give you, and they are, say, some of the things. Let us say density of water in CGS 1 in SI 1000. So density CGS to what do you call SI conversions, you should understand it as what do you call multiplied by 1000. So 1 gram per cc in CGS, SI 1000 kg bar meter cube. So density of water 1 in CGS and specific heat of water 1 in CGS. 1 calorie per gram degree centigrade. So its SI conversion is into 4200. Here I just want to caution you one thing. Occasionally you may find the units of specific heat as calorie per kg degree centigrade. That means part of the unit is in SI, part of the unit is in CGS. So if the student just multiplies by 4200, he gets a wrong answer, because 1 calorie per gram degree centigrade is equal to 4200 joule bar kg Kelvin. So in this case, the student must carefully observe the units. So now the conversion factor will be numerator cal to joule 4.2, denominator kg to kg, no conversion, degree centigrade difference to degree Kelvin, no difference. So your conversion factor will only be multiplication of 4.2. So that's one caution I want to give you. Another thing, similarly, density of air 1.293 gram per liter. In Bernoulli's theorem, while calculating the lift force, you would be using a formula delta P into A, which is equal to half rho into V2 square minus V1 square into A. That rho in that formula is the density of air. Sometimes the examiner may give the density, otherwise the student is supposed to know, which is 1.293 gram per liter. But a comfortable point here is you have to convert it into SI, and no problem, the same value you will get even in SI system. So if you take it approximately, you can take it as 1.3 either in CGS or in SI. So that's one point you got to have in mind. Similarly, another thing I want to tell you is pressure. See, in the case of air bubble inside water at a depth, or in the case of a rubber ball being taken to a depth while calculating bulk modulus, you may need to calculate pressure. And sometimes the student may use the formula HDG. No doubt you can use it, but I want to give you a small tip. Pressure exerted by every 10 meters of water column is approximately equal to 1 atmospheric pressure. So suppose the ball is at a depth of 200 meters, the pressure is 20 atms, you can straight away substitute. 20 atmospheres, and 1 atmosphere is equal to 10 power 5 pascals. So 20 into 10 power 5 pascals, straight away you can use that conversion factor. So I am repeating, pressure exerted by 10 meters of water column is approximately equal to 1 atmospheric pressure, which is equal to 10 power 5 pascals. That's one. Similarly, in the case of air bubble inside a lake, while applying, P1 V1 is equal to P2 V2, you may be asked to calculate something, the depth of the lake or something like that, saying that the radius of the air bubble when it rises from the bottom to the top gets triple, what is the depth of the lake or something like that. So that is one point. Similarly, another thing I want to tell you is graphs. When a question is set on a graph, usually three possibilities are there from the questioning point of view. Either the question can be on slope related concept, or it can be on area related concept, or it can be on the shape related concept. Suppose you are given a question like this. A graph is plotted with acceleration on y-axis and time on x-axis. What the student should do is, I'll just give you two things. Slope is equal to y coordinate by x coordinate. Area is equal to y coordinate into x coordinate. So whenever a question is given on graph, student must think of either the slope or the area. Let us say slope. What does the slope give? A by t. That is y coordinate by x coordinate, acceleration by time, which is rate of change of acceleration, which is called jerk. So if there is a question related to rate of change of acceleration, the student should calculate slope from the graph. Or area. Area is A into t, y coordinate into x coordinate. Area under a graph, most general formula is y coordinate into x coordinate. So your answer should be A into t, at, which is change in velocity. So look at the question. If the examiner is asking about the change in velocity in a certain interval of time, you got to calculate simply the area under the graph. Third thing, shape. Shape is of course interpretation of the way the curve moves. Sometimes the question may be very simple, but something like, I'll repeat one question which I have seen in several competitive examinations. A graph is plotted with BE by A, average binding energy per nucleon, BEPN we call it. BE by A on y-axis, mass number on x-axis. If you remember the graph, you will get a graph of this type, slowly rising, a number of small peaks with dips followed by plateau and then coming down. So if a question is given on shape, what do I mean by asking a question on the shape? Suppose the question is something like this. As the mass number increases, binding energy per nucleon continuously increases, continuously decreases, increases and then decreases, decreases and then increases. Any student who is conversant with interpretation of graph can comfortably answer, though much of physics is not involved in this question. Because as you keep on moving a pencil towards the right side of the x-axis and you observe as x-coordinate increases, y-coordinate also increases with small dips in between, but finally reaches a maximum and then decreases. So as x-coordinate increases, y-coordinate increases and then decreases. So our option should be, as mass number increases, BEPN first increases and then decreases, reaches a maximum and then decreases. So this is a question related to shape of the graph. One more thing is a general hint. These are all general hints. Whenever a question is given on properties like Young's modulus, resistivity, density, etc., you must understand that these are all properties of the materials. They do not change with dimensions. Suppose resistivity of a wire. By increasing the length or cross-sectional area or decreasing the cross-sectional area or whatever it is, resistivity does not change. Properties of materials do not change with dimensions. They change only with factors like impurities, temperature, etc. So that is one question. Whenever such a theoretical bit is given with regard to characteristic properties of the materials, you must think whether option remains same is there or not, in case the change with the dimensions is questioned. That's one caution. You see, after all, ultimately, if a small hint is helpful in scoring 1 mark, you have a better chances of faring. That's the purpose of this video. And one more thing. You have a relation like, let us say, kinetic energy and momentum. You know, we are all aware that it is related as Ek is equal to P squared by 2m. So, suppose I give you a question like this. If the momentum of a body changes by 3%, what is the percentage change in kinetic energy? Your answer is straight away 6%. I want to tell you one small hint here in this small video. Whenever a question is given on percentage changes of less than 5%, your simple method is percentage change in LHS is equal power of the quantity in RHS into percentage change in RHS. So in the question given, where I have given the percentage change? In the momentum. How much I have given? 3%. What is the power of the momentum in the right side formula? 2. So bring 2 before and multiply by 3%. Your answer is ready. However, extremely be cautious. This method is valid only for percentage changes of less than 5%. For greater than 5%, there is a different method. Leave it for the time being, beyond the scope of this video. So, similarly, I am telling you one more example. T is equal to 2 pi root L by G. If the length of a simple pendulum changes by 4%, what is the percentage change in time period? Your answer should be 2%. Because delta T is equal to 2 pi root L by G. That means some constant K into L power half. So what is the power on the RHS? Half into percentage change in length, 4%. Your answer will be 2%. So this is one small hint I want to give you. So whenever percentage changes of less than 5% are questioned on any formula related to physics in any chapter of your syllabus, use this shortcut. Simply percentage change in LHS is equal to power of the quantity in RHS into percentage change in RHS. So that's another hint I just want to give you. So these are all some of the things. And similarly, at some places, in some places, where you are unable to decide the exact logic, you use numbers. This is what I tell the students. Let me say one good example I want to give you and conclude this video. HU is equal to W plus KE max, photoelectric equation. So, what incident photon energy is equal to work function plus maximum kinetic energy. So, I have seen several times this kind of question in different exam. So, question is like this. When the incident photon frequency is double, KE max is double, more than double, less than double, cannot say. 70% of the students get tempted to answer this as doubled because they think that while studying the law, they will study that as photon energy increases, KE maximum increases. In other words, they think that it is directly proportional. But you know, it's not a proportionality in product, it's a proportionality in sum. So, it's not something like z is equal to xy. If z gets double, when x is constant, y also gets double. That's not the way. So, to answer this bit, what I suggest is, you apply numbers. Let us say HU is equal to W plus KE max. Let us say incident photon energy 5 eV. W fixed. Metal, for that metal it's fixed. K, let us say 2 eV. KE max is how much? 3 eV. Now, what is the question? Incident photon frequency is double. So, incident photon energy also gets double. Now, LHS becomes 10 eV. Work function is how much? W. Metal same. So, 2 eV. So, now what is the KE max? 8 eV. So, when incident photon energy is 5 eV, KE max is 3 eV. For a metal of work function 2 eV. When the incident photon energy is double, for the same metal of work function 2 eV, KE max is 8 eV. So, is the KE max doubled or more than doubled or less than doubled or remains same? More than doubled. So, this is a simple way of answering in some areas. So, these are all strategies or simple hints so that in the exam hall you can use them as and when they are needed. So, especially with regard to units, you should be cautious, and especially with regard to these areas, you should be cautious. Some I mentioned in this video because with exam a couple of days, I just don't want to deal with anything more. These are all general hints. These are only based on the subject, which may be useful while attempting the MCQs. Okay then, good day and good luck.